Hello everyone, today I'm gonna to introduce the semaphore to you guys. So first, let's see what is a semaphore. Technically, semaphore is a variable that can store an integer value. So basically it is an integer variable. But it's an integer that can control each process in your computer. A semaphore is an integer value used for signaling among processes. To make it easier for you to understand, I would like to use the following example. As we all know, because of the COVID situation, the store need to set an indoor capacity limit. So let's say the store has a limit of 10 people inside, and in order to control the capacity, a doorman is needed to stop the customer when the capacity is full. So the semaphore here is the doorman, and the store in our computer is the ready queue, and the customer here is the blocked queue in our computer. So in this case, when the capacity of the store is full, the customers will be asked to wait outside of the store, and the staff inside the store will tell the doorman to wait until the next instruction. In our computer, the system will send a wait instruction to the semaphore to tell the semaphore that blocked every process in the blocked queue. And when there is a free spot in the store, the doorman will allow one customer into the store, and in our computer, system will send a signal instruction to semaphore, and the semaphore will allow one process in the blocked queue into the ready queue. And in the next case, we have 0 customer in the waiting line, but also we have 2 free spots in the store. So what's the doorman gonna do? Yeah, he gonna allow the next 2 people go into the store directly without any waiting. So it's acted the same way in the operation system. The system will send us 2 signal instructions to the semaphore because there are 2 free spots in the ready queue. So the semaphore will allow the next 2 process directly into the ready queue without waiting in the blocked queue. And after this, the capacity will be full in the ready queue, and if there is still a new process want to go into the ready queue, the semaphore gonna block it in the blocked queue. And this is exactly how the semaphore works. So how the system can achieve this, or how the system can control the semaphore. As I mentioned before, the semaphore is actually an integer, which means it can actually act as a counter. So when the semaphore value is negative, the process will be blocked. And if the semaphore value is non-negative, the process can be executed or into the ready queue. So the system makes the semaphore functional by changing its value. And there are only 3 operations for the semaphore. They are initialize, which initialize the semaphore to a non-negative integer value, and the semwait, which decreases the semaphore value. If the value becomes negative, then the process executing the same weight is blocked. Otherwise, the process continues execution. And last one is the sem signal. it increases the semaphore value if the resulting value is less than or equal to 0. Then a process blocked by a semi-wait operation, if any, is unblocked. Let's see an example of the semaphore. So in this code, the first part of the code creates a struct, semaphore struct. The struct includes one integer value, which is actually the semaphore itself, and also a blocked queue. And in the semi-wait function, the semaphore value will be decreased at first step, and then if the semaphore value is a negative value, the process here will be placed into the blocked queue. If it's not the negative value, it will be executed into the ready queue. And in the SemSignal function, the semaphore value is increased at the first step, and if the semaphore value is smaller or equal to 0, which means there are processes that's in the blocked queue. So the first process in the blocked queue will be removed to the ready queue, the ready list. If it's not satisfied this equation, so the process will be directly go into the ready list. Okay, so there are actually two types of the semaphore. One is counting semaphore and another is binary semaphore. The only difference between these two is that the counting semaphore can take on non-negative values, which is exactly the example I used before, the COVID situation stores. And the binary semaphore can only take a value of 0 or 1, which I am going to explain in the next slides. Here we go. So there is an example problem of the binary semaphore. So the question is, due to the COVID situation, Toronto Zoo only allow one person to use the public washroom. Create an implementation using semaphores that only allows the washroom to serve one person each time. Assume that there are two people, Jack and Rose, waiting in line, and each person will stay in the washroom for a random period of time. Let's see the solution. Okay, so the most important part of the solution is the thread function here. So the thread function is to record who are using the washroom and who finish using the washroom. So the first step in this function is to print who are waiting for the washroom to use, and then when this person go into the washroom, and the semi-wait will be executed to tell the system that the washroom is not available. And the semi-wait will decrease the semaphore by 1 and tell the system that other process should be blocked. And next step is to print who are using the washroom, and then the program will sleep. It will stop for a random period of time, and then this person will finish using the washroom and go out from the washroom. The semi-post will also be executed at the same time to tell the system that the washroom is available. And in the main function part, the first step is to initialize the semaphore. So I called the semaphore washroom, and the value of the semaphore is 0 and 1, which means it's a binary semaphore and only allow one process or thread go into the ready list per time. And the rest of the main function is just to create two threads called Jack and Rose and execute these threads respectively. And the result is shown on the right. You can see it shows the Jack is waiting outside, Jack is in washroom and finish using the washroom, and then it's the Rose's turn. So it works very perfectly. And thank you for listening, and this is all the content I want to talk to you today. Thank you.